Hello. So we're ready to go on with a little more complex query. We're going to introduce you to an inner join. And an inner join can be thought of as complicated, but if you understand why you do it, it's actually pretty straightforward. So let's go ahead and dive right into this. So we can join two tables together logically, and relational databases store data in multiple tables, and we'll take a look at an example of that. And often these tables are related logically. So an example might be a student and course table, which we'll look at in just a minute. And joining the tables together would allow us to find all courses for a particular student. So we can join these tables using a SQL select statement with a join. And foreign keys often define the relationships between the tables, but they're not required for joins to work. And good database design will have foreign keys for related tables. So the question you may have is, why is the data in more than one table to begin with? So let's say we had some students here with some courses, classes that they were taking. And what you'll notice immediately about this is that there is some data that's repeated. James Smith is taking 3 classes and Susan Fox is taking 2 classes. And what you see is James Smith is repeated over and over again, and Susan Fox is repeated, and also the Intro to SQL class is repeated. So this presents some interesting challenges for us. First, there's an inefficient use of storage. We have data that's being replicated or repeated over and over again unnecessarily. Also, this is hard to maintain. So let's say that we needed to change the course description of our Intro to SQL course, we would have to change it in 2 different rows in this table. So let's look at a different way that we might do this. So a relational design would take this and break it into 2 tables. It'll actually break it into 3, but let's look at 2 specific ones to start with. First is some type of a student table. And so what you'll notice here is we have each student listed with a unique identifier. Then we have each course listed with a unique identifier. And then what we need to do is be able to join these together logically. And this is not the join that we're talking about, but relate is probably a better term. So let's relate the tables. Here's our student table, here's our course table. We can have a table in between that basically says student 1, which we see here in the middle. This student 1 is James Smith, and he is enrolled in course ID 1, and if we go down here into the courses table, that is the Intro to SQL course, and you can just read through each one of these. So what you'll see immediately is you'll say, well, wait a minute, there's a lot more, there seems to be more data, and that is true, but it's a smaller amount of data. And the other thing is, if we decide that we need to go and update the description of our Intro to SQL class, we would just change it in one table, and then every place that was used, it would automatically get that for us. So in SQL Server, there are some SQL Server diagrams that can show you the relationship between tables, or what it thinks is the relationship between tables based on the foreign key relationships. We'll take a look at that. And we're going to look at 2 specific tables. So we won't be joining 3 tables together, but we'll just be joining 2. We're going to look at product and product model. And so this diagram is going to show, this diagram shows us that there's a many-to-one relationship. So there is one product model, and there could be many products of that model. And the common value that logically joins these 2 tables is the product model ID. So what you'll notice is product model ID here, and then down in this you'll see product model ID here. So let's just look at what the join will look like. Well, first, before we do that, let's talk about the different join types, and we'll do some videos on each of these. But there's an inner join, an outer join, a cross join. By default, if you don't specify, you're going to get an inner join. It's probably the most common join that we have. And then you can have full left or right. So here's an example. If we wanted to select all rows from table A that match exactly rows in table B on a specific column, so in our case, select all rows from the product table and all rows from the product model table, where the rows match exactly, then this is the general syntax. Select and you list the columns from the first table that you want in the join, and then you say inner join, and then the second table on, and then you say the column from the first table and the column from the second table separated with an equal sign. So in our example, it might look like this. Select star from production product model, inner join production.product on production.product model dot product ID equals production.product.product model ID. Okay? All right, so let's try it out. Enough with the slides. Let's actually fire up SQL Server and try it out with those tables. So the first thing I want to show you is the database diagrams. So here is our AdventureWorks database. And if you'll right-click and select New Database Diagram, you can pick the tables that you want. And so if we were to pick them all, it will build a diagram for all of those tables. You'll see it sitting here going through, and what it's doing is it's looking at the foreign keys that are defined. When we get into actually creating tables and defining schema, we'll talk more about foreign keys and how you set them up. But this is what it's doing. And there's a lot of tables in this database. So it's working through all of these. And when it's done, we'll show you the diagram. So that took a minute or so I decided to pause the video. We can zoom this out. And so you can see all the different tables that there are and the relationships between them. And then you can save that database diagram. The one thing to be aware of with database diagrams is if you make changes here, you can actually change schema. So what I'm going to do is I'm actually going to do a new database diagram, and we'll just do it with the two tables that we're interested in, which is the product and the product model. So we'll just pick the product. The product model. Now if we just add those, that diagram comes up a lot quicker. And here you see the relationship between the two tables. Okay? And you can drag these around all that you want and just kind of see what that looks like. This is useful to just give you an idea of what the database structure looks like. So let's go ahead and do our query. So we will say select, and I'll just say select star for right now, from production remember, production is our schema, so we're going to select from product model, and we are going to do an inner join, and we say inner join in the second table, which is also coming from the production schema product, on, we say production dot product model ID is equal to production dot product dot product model ID. Let's run that query. So let's go ahead and run this. And what you'll see is an interesting thing. We actually pulled back data from both tables. So the reason we got data from both tables is because we said select star, which says give me all the columns. So if you're joining multiple tables in a single query, you'll get all the columns from all the tables. So what you'll notice here is that because product model was the first table listed, if we go over here and look in production product model, move that back out a little bit, and we look at our columns, here's all the columns over to modified date. So these columns right here, those columns are all from the first table, the product model, and then all the rest are from the product table. So let's pare down a little bit the fields, and we know how to do that. We just change this to whatever we want. Now the difference here though is that because we're pulling data from multiple tables, we need to specify the table that the column is coming from. Before, we haven't had to do that because by default it came from, we were only dealing with one table, and so by default it just came from that table. So for example, if I were to say product model production product model, and let's say we just wanted to see the name that came from that table. Now, and then let's say that we wanted to see the name from the product table. Okay, so if we do production product and then the name column, let's run that query and see what that looks like. Okay, so now this name is coming from the product model table, and this column is coming from the product table. So what you'll see here, an example in the database, is things like this. The model is HL Road Frame, but you'll notice some different names for it in the product itself. And so that's how we join two tables together. And obviously we could use column aliases, as we learned. We wanted to say something like that. Okay, so that's an introduction to how you can use an inner join. Hopefully this syntax makes sense to you. If you really break it down and just think about this as a SQL statement that we've done up until now. And by the way, we can also go right in here and add a where clause. So we could say where name is equal to well, let's do a like. And let's do HL%. Let's do something like that. We need to use the fully qualified name of the column. So now you'll see it's only pulling back that data. We could also order by the name. So everything that we've done so far, you can still do all of those same things. You can apply the where and the order by. So this is what the complete syntax looks like with a where and an order by included. This is the part right here that's the join. So remember, you specify the first table, you say inner join on the second table, you say on, and then you give the two columns, one from each table that you're going to match the data on. So I hope this has been useful. We'll go on and look at some other ways to use inner join and use outer joins as well. And so hopefully this has been useful. Please let me know if you have any questions. And we always appreciate likes on the videos if you'd be so kind to do that if these have been useful to you. Thanks.